All right, time to talk about pointers. I was putting this off as long as possible, but I think it's really important since I'm starting to have them pop up in almost everything I show you for you guys to have the opportunity to at least learn about them. Um, Pointers, in my opinion, is single-handedly the one reason or thing that scares people away from learning C and makes them learn other languages first or even never learning C, such as languages like Java and C Sharp, because those languages don't have direct access to pointers in them. I'm just going to go ahead and say that I think it's I think if you can grasp pointers and you can learn pointers, then you can make yourself become more powerful than and more capable than at least three-quarters of all the programmers out there, especially the ones that don't use C. I mean, even some C programmers don't use a lot of pointers nowadays. They're just extremely powerful. They give you direct access to the machine's memory, and they're a little bit hard to grasp at first. And I don't expect you guys, if you've never seen them before, to get them watching this video the first time. But you can watch it again, and you can go over it in your head, and one day it'll just click, and you'll feel awesome. So I'm gonna go over them. I'm gonna try to go as slow as possible. This video is all just concepts. There's no actual programming in this one video. It's just a break from my other episodes, and then after this episode, I'm going to go back to game programming, and you guys will have better understanding of pointers under your belt. When you see them, you'll be like, oh, I know what that does. So pointers give you lower level access to programming. The lower level you go, the more control you have over exactly what the computer is doing in the code and exactly how the resources are managed. So you can never blame anybody but yourself if the game or program isn't going fast enough, because you're working at the lowest level you can go without using assembly. Where can you directly use pointers? C and its direct ancestors. So even though this lesson's about C, if you're using C++, you can still use pointers. Objective-C uses them a lot, but you don't have to dive into them quite as much in that language. So native languages use pointers is the best way to describe it. Non-native languages don't. They do, but you can't break into them and actually use them in a useful way. Those languages like Java, C Sharp, definitely not JavaScript or PHP. Those languages, the pointers all happen without you realizing it. All the memory is manually or automatically managed for you. So you've been hearing me talk a lot in the other episodes about value versus reference of variables. Here's an example of passing arguments to a function. The ones that are highlighted in blue have been passed by reference, and the ones that are not highlighted in blue are being passed by value. As I told you before, passing something by value is copying it and all of its stuff in there. And if it's a heavyweight thing, like a structure with a lot of hierarchy, you just don't want to copy it. You want to pass a reference to it, and if you are going to copy it, you want to be more careful about how you're going to do so. So, for example, that second argument, yref, that's a pointer to an integer, so that's a reference to an integer. Sum struct, the second one, is passed by a non-constant reference. When I say non-constant, I just mean the word const isn't there, so you have read-write access to the memory. Thing you're referencing. The last two I put as an interesting note. I really wanted to make it clear. Those two are exactly the same type. The last two array references. They both are pointers. The only real difference and the only reason why those differences are there in the language is the second to last one, array ref. That one really drives it home that you're passing an array. You wouldn't pass a generic pointer reference in like that. And that second one is more generic. It says, well, it could be an array, you can tell because of the name, but it's really just a pointer to one or many integers. So you're probably like, what the heck is he talking about? So that's what I was just saying. Let's get into exactly what pointers are. Pointers are references to memory. They are memory addresses. They're used directly by the CPU to access and reference memory on the computer, or RAM. This is how you declare one. That asterisk is the difference between declaring a regular int and a pointer to one or many ints. That's how you declare a pointer, that asterisk. And this is how you would use a pointer. So if you wanted to obtain or store a reference to x, regular old x, inside that variable called pointer or PTR, you would set it equal to what that ampersand is called is the address of x. So by setting the pointer to the address of x, you have created a reference to it. And this diagram shows you what that would look like. All pointers in diagrams in this video are green circles, and all variables or actual memory are squares and blocks. So that's what a pointer to x looks like. Pointers have properties which make them what they are, and I'm going to go over them right now. Pointers are variables. They're just like declaring any other kind of data type. They're just a new kind of data type. That star takes it from being the data type you put in front of it, such as int, to being a pointer. All pointers are the same size. They're 4 bytes or 32 bits on a 32-bit architecture and twice that on 64 bits. It doesn't matter if you have a pointer to a toilet, a banana, a man struct, or any kind of structure or an array. The pointer itself is always the amount of bytes of the architecture of the machine. It doesn't change. They have a base type, what they are pointing to. That's what that int before the star means. It tells you the pointer is pointing to int, which you later will see as important. They're assignable. So once a pointer has been assigned to be pointing to something, it can be changed. It's malleable. You don't have to always reference the same thing with the same pointer. You can reuse it and reassign it to point to something else. And this is the most useful aspect of them. They are dereferenceable, meaning if you have a pointer to something, you can dereference, follow that pointer, and access the reference data and maybe even modify it. And then, of course, they're incrementable. This is one of the hardest aspects of pointers for people to understand. But basically, you can use a memory address, which is a pointer, and walk through memory forwards or backwards from that original pointer position. You can actually move the pointer around to point to different bits, not bits, but bytes of memory. Let's go over the easiest part first, assigning a pointer. So let me just see what I wrote here. So if you have, say, for example, a single integer variable or an array of integers and a pointer, you can actually assign the pointer. Well, first you can assign it to null. Null is the universal constant for an undefined, or better yet, an invalid pointer. If you set a pointer equal to null, you're saying it points to nothing. Null is actually a constant of 0. It's like setting the pointer to 0, the memory address 0, which is not a valid memory address. You could set the pointer to, like I showed you in that first example, the address of. That ampersand is called the address of operator. You could set a pointer equal to the address of a variable, or to reference the variable. So pointer will now reference var. Or you could set it directly equal to an array. And notice there's no ampersand there. And I'll explain that later. But if you want, by default, the name of an array is a reference. Remember, passing arrays by reference. So if you just set a pointer equal to an array, you have a reference of that array. It's just almost like having another name to point to it. And of course, there's many other ways to assign a pointer. You can return them from functions and do whatever the heck you want. So, dereferencing. When you dereference a pointer, you follow a pointer. So the best way to talk about that is there are many ways to do it. The first one is the called contents of operator. This is very confusing because the people who invented C decided to reuse the asterisk in a different place and give it a different meaning, which is very annoying. But long story short is if you're not declaring a pointer and you're just using the pointer variable, if you want to assign not the pointer but what its contents of the pointer or what it's pointing to, you just put a star before it. That star dereferences the pointer. And this will basically set x to 50. If the pointer is pointing to an array, believe it or not, you've been already dereferencing pointers without realizing it if you've been using arrays. Putting those square brackets after an array name or a pointer dereferences that pointer, and it actually dereferences the ith element of the pointer array that the pointer is pointing to. So those square brackets actually perform a dereference to the pointer and access the ith element. So like pointer sub 0 equals 50 would set the 0th one to 50. When you're using a struct, it's much like when you're using the regular int or use the regular primitive data type. You just put the address of the struct to obtain an address or reference to it. And then just like when you use struct .x to access a property. When it's a reference or when it's a pointer to a structure, the dot doesn't work. You have to use the minus greater than, or I actually call it the pointer because it looks like one. The struct dereferencing. I don't know what that operator is called. I just call it the dot for pointers. So it's a minus greater than, and you're arrowing into the thing to access the memory it points to. Time for an illustration. Here's some properties of pointers illustrated. The first one I want to talk about is incrementable. So suppose you have an array of 10, 24, or 1K elements, 1,000 integers basically, and you start them all out with 0. So it's just 1,000 integers, they all contain 0. And you create a pointer to that array. Well, that pointer actually points to the first element of the array. Now what happens if you do this? It seems kind of weird. You're not adding 2 to the 0 inside here because you're not accessing the array elements. You're not dereferencing here. You're actually moving the pointer, adding 2 to the pointer. Because the pointer points to int, the pointer actually changes and moves 2 elements into the array, and now pointer is pointing to the actual, you've offsetted the pointer essentially by 2 integers worth of bytes. You've offsetted it 2 elements of the array, and now it's pointing at the second one. So take a wild guess what this one will do. You're setting the pointer equal to array plus 1023. That's 10,023 elements into the array. Now pointer points to the last element in the array. That's pointer arithmetic. It's very hard to grasp when you're starting out, but it's one of the single most powerful things because you're able to march through memory arbitrarily and have full control over your memory because arrays your memory like everything else. Man, I screwed up this slide. What does this mean? Well, believe it or not, unless I screwed this up some more, those last 2 lines are exactly the same thing. They mean the same thing. Think about it. If you're taking an array and you're moving 1023 elements into it, you have a reference to, or an address of, the last element. So of course that's equal to or the same thing as the address of that same element. So those 2 lines perform the exact same operation. And this brings to one of those universal truths about C and one of the laws of pointers they always teach you about when you're learning C. The name of an array is actually always equal to the address of the first element because an array's name, the variable name, is a memory reference. Therefore, it's a reference to the beginning of the array. It's the address of the first element. It takes a while to get a hang of this, but this is a very important concept to drill into you as you move around with pointers. All right, so more about pointer arithmetic. I didn't change anything between the second slide and this one, at least in the beginning, except for the type. Notice now instead of the type being a, I can't just skip this slide. Now instead of the type being an integer pointer or an int star, it's char star. This is very important because now the assumption is that you are actually an array of bytes or an array of characters instead of an array of ints. So what will happen is if you assign the pointer to point to array, or not point to array, but equal to the array, and you're actually pointing to the beginning of the same array of ints, but it's going to treat it or interpret it as if it's an array of chars or bytes. So when you do this pointer plus equals 2, it actually offsets the pointer based off of the number of bytes in the pointer's base type. So you actually now are pointing to the second byte inside of the first integer. This is crazy because you can actually now move through memory without regard for anything of the underlying data type. You can set a char pointer equal to anything you want and always examine the individual bytes regardless of the original type. You cannot do this in Java or JavaScript, at least not without some very inefficient sloshing around. This is the most efficient way you can access memory. So what happens if I move it 8 forward from there and then back 1? You get the 7th byte, which is the last byte of the second int of the array. Once again, very powerful stuff. So let's look at another example. I know I'm moving kind of fast, but I wanted this video to be under 15 minutes before I get to the part 2 of all this. So let's look at the 32-bit example working with a struct. I have my man struct from my earlier examples, which I've been showing you guys a lot from my earlier game programming examples. We went ahead and declared one. We also have a pointer to a man up there, but we have the actual man struct equal to some things. So I set man.x equal to 50, and then I take a reference to man with pointer, and then I actually set the same variable to 60 by dereferencing the pointer to man and using the arrow to access X. So what does this start looking like? First, you have a pointer to man. Under the hood, you actually have those gold things are the bytes. You have 50, 0, 10, and a null pointer for the name. And by the time you get down here, you've actually changed the value in that first property X to 60. You've changed the original man X position via reference, which is very cool. So what if, I hope I didn't duplicate this slide. What if you do this? What if you have the same idea, but you set the name? Well, if you look carefully in the structure, you'll actually see that name is a pointer. It's been a pointer all along. And in C, strings are pointers. And you can actually set them equal to a special construct in C, which is the quotes, which actually define for you string literals. So when you get to this line, C will actually create for you a static array of characters and create the string for you in memory, and then your pointer name is pointing to that array. Strings and pointers are very intermixed in C, and it makes string programming very hard to understand when you're starting out. But once you get the hang of pointers, it starts to paint a clearer picture. There's still some stuff I haven't talked about with strings, namely the fact that when you have a string, it's an array of characters, but the way you know that you're at the end of the string, or the string is over, is you create a zero character or a 0 byte or a null byte to determine that you're at the end of the string. That's called a string terminator. I've just gone off on a tangent though, so I'm going to keep going. But you can guess, since strings are pointers and they're pointers to an array of characters, you can guess what this line here is going to print out. It's going to actually access man.name. It's going to access the second element of it and give you the end character, which is the third element, 0 counts, and give you the end character within that array. So this is another way of actually marching through memory and a very cool way of actually accessing characters of a string. So now that I've gone through pointers with you guys, probably a little faster than I would have liked to, I'm going to talk about things that can go wrong when you're using them. Because whenever you're using an app or a program or a game or anything and it crashes or freezes up, I can guarantee you it's because someone somewhere made a mistake with pointers, at least when you're using lower level languages like C. The most common thing that people, well, not common, this is one of the most uncommon mistakes actually, but if you have a pointer and you set it to null, you can't dereference it. If you dereference a null pointer in any way using any of those dereferencing methods I talked about on the dereferencing slide, the program will crash. There's no way to recover from this. It's a mistake. Don't do it. You cannot dereference an uninitialized or wild pointer. I don't know how much of this I covered in the original lessons, but if you declare a variable in C and don't set it to something, you have no guarantee what's in there. It's basically the last thing that was in that memory address in RAM, which is called wild, uninitialized. If you do this, it'll most likely crash. The worst thing about it is it won't always crash, and these mistakes actually won't pop up until you've shipped your game, and then it's crashing, and then you feel like an idiot or an asshat because you dereferenced a wild pointer. So always set your pointers to null if you're not using them, and then always check if they're not null before you dereference them. It's the best way to avoid that. Also, this is a very, very common mistake. You cannot dereference outside the bounds of an array. As I told you, using square brackets actually dereferences a pointer when you're working with an array. If you go outside of the bounds, you will likely crash. Not always because of things about paging and stuff, but it's a bad thing to do. Remember that second one, the 10th item, is actually the 11th one because 0 counts, and that will also cause a crash. So that's a mistake. And beware of more peril. This one is very counterintuitive and actually made me angry when I was learning C when I was younger because it doesn't make a lot of sense when you're starting out. If you set a string equal to some quotes and you're just capturing a pointer to those quotes, like I showed you in that other slide, it's actually called a string constant, and it's actually read-only memory, and you can't change it. If you try to modify that first one, it'll crash. What you got to do instead is actually create storage for an array. And because C is a weird language and there's these little exceptions all over the place, kind of like the English language, that second one actually copies the array constant into the array. It's one of the few times in C where setting an equal sign between pointers and non-pointers actually causes a copy. But best way I can tell you about this slide is just kind of keep it in your mind if anything goes wrong with a string and you can't figure out why. This is probably what happened. So that's the end of the tutorial on pointers. And I went way over with 20 minutes. So I'm going to go ahead and end here, and we'll talk about dynamic memory next time. Thanks, guys.